Howdy, and welcome to my course, Introduction to Working with GPT 4.0 Realtime with Tau.js. Wow, that's a bit of a mouthful, isn't it? I'm Daniel Stern, the Code Whisperer. In this course, we're going to learn to use this very crazy technology called GPT 4.0 Realtime, which is a technology we can use to build real-time voice apps like customer service, automated salespeople, video game NPCs, you name it. And we're going to use it with a special technology I invented called Tau.js. So let's have a preview of what we're going to cover in the upcoming lessons. First, about the author, which we'll do right now. I'm Daniel Stern, the Code Whisperer, and I'm narrating now and also do the demos in this course. My background is in graphic design, but I've become something of an artificial intelligence and GPT enjoyer as time has gone on. And in addition to being a Google Cloud certified professional machine learning engineer, I've authored many courses on both AI and computer development, which we use throughout because you also have to be able to program computers to work with GPT real-time in this way. In the coming clip, we'll learn about real-time GPT and what exactly that means. If you already know what it means, then it'll be a little bit of a review for you. Then we'll learn about Tau.js and do a walkthrough of the Tau.js documentation. You'll probably be less familiar with this because this is a library I invented just a couple of weeks ago, and the purpose is to take the huge amount of code you would need to write to get real-time GPT working and be able to do it in just a couple of lines of code. After that, it's everyone's favorite, the tutorials. So in our series of tutorials as part of this course, first we'll get to Hello World with our tool. We'll get an AI saying Hello World to us, or really whatever we want. In the next part of the tutorial, we'll output voice. So we'll use the Tau.js debugger to have the AI output voice, and we'll listen to what it has to say. Finally, in the third wing of our little tutorial, we'll input voice using the debugger, so we'll have a full voice interaction loop using Tau.js before we're done this course. It's going to be great, and just taking this free course will catapult you ahead in the world of developing with GPT. So we'll get started with a review of real-time GPT and Tau.js. So in this lesson, we'll learn about what the real-time API is. Here we are on OpenAI's page about the real-time API, and in the way that smart people who get paid too much tend to do, it spends a really long time talking, and it's actually pretty difficult to understand what is really going on this page with all the stuff. But don't worry, because Code Whisperer is here, and I'm actually just going to explain to you what real-time API is. So we're all familiar with interacting with ChatGPT. We type something in, and a couple of seconds later, ChatGPT responds with a text message or a voice or an image, etc. Now, so far, regular ChatGPT and the real-time API are the exact same, but here's the difference. ChatGPT usually responds overall in about 2 to 3 seconds. There's a number of reasons for this, which is that ChatGPT isn't optimized for speed in the same way real-time is, and also, every time you make a request with ChatGPT, it makes a new HTTP connection. Now, the real-time API basically has a little ChatGPT inside, but it's optimized to be faster. And we only create a connection once, known as a session, and then we repeatedly reuse that session to communicate with our GPT. So if you wanted something more interesting and exciting, well, you're actually not out of luck because there's a second very interesting property about the real-time API. So in addition to being faster than just using the normal GPT endpoint like 4.0, the real-time API uses something called a text-to-speech neural network, which means that when we're using voice output, look at it this way. Normally in ChatGPT, if you want voice output, first it outputs the text, then it transcribes it into voice using a different software. But with real-time, it's actually making the voice token by token. Real-time API thinks in speech when speech is enabled, which is a really weird kind of crazy property, which creates some emergent and interesting effects. Most interestingly, very interesting and dynamic real-time voices that get generated. They can be very emotional and create a lot of feeling and impact. So to summarize, the Realtime API is just like a normal GPT completions endpoint, except it's faster and has much more powerful voice capabilities. Okay, so where does Tau.js fit into all of this, and why should we care about Tau.js? Is it really going to help us work with real-time Websockets a lot? And the answer is yes. So Tau.js is a Node.js library developed by yours truly, the Code Whisperer, and basically it does as follows. You'll recall that Realtime API is faster than the normal ChatGPT API. That's because it uses a technology called Websockets, which are way faster than normal HTTP, but harder to develop for. So if you want to start from scratch, you have to use this clunky WebSocket API to actually interact with Realtime API, but not anymore thanks to Tau.js. So Tau.js basically wraps all that confusion in a very simple async interface and makes it very, very easy, as we'll see, to use real-time audio. So in this lesson, I'm going to walk us through the documentation, which is here at github.com/danielstern/tau.js. Go ahead and make sure you starred this repo. It'll mean a lot to me, and let's review the documentation. So at the top, it explains what Tau.js is, just like I did. It's a way of using the real-time API on GPT. On this little code example, you can see this is a complete code example, and this is enough code to generate voice output with Tau.js. If you're excited about that, you're in the right place, because we're going to be doing a lot of low-code, high-yield development in this tutorial. Now, in addition to offering a convenient interface, Tau.js has two critical features that we'll be using frequently during development, which aren't part of the Realtime API on its own. So the first is cost estimation. When you use Tau.js, it estimates how much your session costs. It is just an estimate and it's not exact, but it adds up all the costs for all the requests you make in one particular session. If you're like me and you're obsessive about cost, this is a really cool feature, and it helps give you a good idea of how much you're spending. You might not realize that having a conversation with a given input may run into several dollars if you're using an expensive model. With cost estimation, we're not going to be blindsided by that, and we can build being prepared for that right into our code base. Next, as we'll see in the demo, it includes a debug server. One of the hardest parts about working with real-time audio is the format that the sound comes in, which is in PCM audio data, which is not handled natively very well by Node or by Windows. So the solution to this is to use a web browser, which are designed to work with PCM audio data. And to do that, Tau.js has built a complex and pretty impressive React application that lets us listen to audio that comes out of our session and also input audio using our mic. So without Tau.js, this would be an insane amount of engineering that we'd have to do. Below that is a quick start guide, which is pretty similar to what we're going to be doing in the upcoming lectures. Although it is a bit different, so I do encourage you to go through all the tutorials and examples on the GitHub page after this course if you're interested. Below that are information on understanding the debug server, which we'll do in the upcoming introduction, and also a series of examples. I put a lot of work into these examples, and they're great practice. They all work. You can just drop this code right into any JavaScript file and they'll work. You can build a real-time translator, a dramatic performing Vocaloid, a language tutor that can tutor in any language and provides feedback, a function calling assistant in real time, that one's so cool, and an ensemble performance, which actually uses a bunch of different sessions all at the same time to create like a performance. So we could make an entire course on any one of these examples, but go ahead and spend some time with them after if you're interested. After that, we get to the API reference, and this is where you can go to see all the different arguments you can use for all the different methods. For example, in this course, we don't really have a lot of time, so we don't spend a lot of time working with the individual session options and Tau options that we have in our session and response creating. but all the documentation, all the information you need is here on the GitHub page. So keep this open at all times when working with Tau. And of course, we'll just get to the bottom of here. So this is all the API documentation, a little FAQ. And the best place to go if you have any questions or you want to get involved and help with the library is just here on issues. That's how you can get directly, basically, in touch with me to share your thoughts or ideas or bugs about the library. And that's about it for an overview of Tau.js. Let's jump right in and get started with some code. Alrighty, here I am in Visual Studio Code. I have my empty project open, and in this clip we're going from empty project to hello world with GPT 4.0 Realtime and Tau.js. It's going to be a lot of fun, so get ready to code along with me at home. So I've got my empty project. First, we'll make a new file, and we'll call it package.json. Yes, this application is in JavaScript. If you like Python, that's great, and it's time to learn JavaScript right now, as JavaScript is also a very good language and more suitable for working with this kind of application than Python. So here in package.json, we'll specify type is module, which we want to have set for any projects using Tau.js. Now I'll open up my terminal, and we're going to install Tau.js. So I'll say npm install save at tau-js/core. Excellent, and as you can see, package.json is updated with my new dependency on Tau.js. Now we're just about ready to get started. All we have to do is set our OpenAI API key. So to get your OpenAI API key, you head over to platform.openai.com/API keys, and you create a new secret key. Here are mine, but there's no harm as you cannot see the keys, just a tiny fraction of them. So on Windows, we set that as follows with setx OpenAI API key. Note how OpenAI is one word, and then we just copy and paste our API key in. So go ahead and do that. If you're on Mac, go ahead and ask ChatGPT how you set an environment variable on Mac and set that. Now, if you're working in VS Code, you'll have to restart VS Code, so go ahead and do that after setting your OpenAI API key environment variable. Great, so now we're almost at hello world. We'll create a new file and call it src/index.js. Now we'll start by saying import create session from Tau.js. Now, create session is the main method that's exported from Tau.js. Sessions represent a WebSocket connection with Realtime 4.0 GPT. So every time we create a new session, it's like creating a new assistant. This is the main method with we interact with real-time models in Tau.js. So we'll make a new agent, and we'll say let agent equal await create session. Now, there's many options that we can input here in create session, but for now, we can just leave it blank and go with all default options for this hello world. Now, we'll issue a system instruction to the agent. We'll say await agent.system, and we'll say no matter what, just reply with hello world. Now, we can call methods like agent.system as many times as we want, and it won't generate a response. To get the GPT to actually create a response, we have to call agent.response. So we'll say let response equal, and we'll say await agent.response. And finally, we'll log our response. Console.log response. As a last step, we'll say agent.close, which ends the WebSocket session and will allow our terminal instance to exit back into the command line. Excellent. So that all looks good. Let's give it a try. Make sure that your OpenAI API key variable is set, and we'll say node src/index.js. Excellent. So here we have our response that's come in from the server. Let's take a minute to take it apart. So there's lots of very interesting values that are returned from a Tau.js message. At the bottom here, we can see transcript, which is the text that's returned. It returns hello world because, after all, this is a GPT and it can output anything that we want. We can consider our getting to hello world task completed. Let's look at this rest of this information here. The audio deltas is the base 64 encoded audio data. This response actually produced audio, though we didn't hear it because the debug server is not set up. We'll set that up in the next lecture, but that's where we find the raw audio data. The usage information is included with the request, and it includes how many tokens were spent of each kind, and also an estimate of the usage cost. So you can see our efforts here cost us somewhere in the neighborhood of 1/10 of 1 cent. Additionally, there's some interesting information in the first audio delta compute time and the compute time. These values tell us how long it took to get a response. When we're working with real-time WebSockets, things going fast is basically our chief priority. If we didn't need things to go fast, we use a different kind of GPT connection. So we'll spend more time getting to know what kind of values Tau returns as things proceed. And there we are, we're at Hello World. You can take a bit more time now and play around with this. This is basically a fully functional GPT assistant session. So you can put literally any instruction that you want and it will comply. So let's just say, please translate the most recent user input into Italian. And after this, we'll say await agent.user. And this is just a way of inserting a user message. This is like if you would have typed it into ChatGPT yourself. And we'll say real-time WebSockets, Tau.js, the code whisperer, and you are all super cool. Let's run our code. WebSockets in tempo reale, Tau.js il code whisperer, e tu siete tutte superfici. Excellent. So we got to Hello World, but that's not all because we still have more exciting tutorials in this course. In the next tutorial, we'll learn about using the voice API and the debugger. Alrighty, so we've gotten to Hello World and we've gotten the terminal to output text from our model session. But that all is just a small fraction of what we can do with real-time models and Tau.js. So in this clip, we're going to explore some of the voice functionality which we can input and get as output from these very cool real-time models. So I'm here in my Visual Studio Code right at the end of the previous demo. Now, we saw that when we get audio coming in from the create session method, it comes in the form of audio deltas. We need to process the audio deltas somehow, but luckily we have a debugger that comes with Tau.js. So first we'll install the Tau.js debugger CLI. So I said npm install g at Tau.js-CLI. The g is important as that allows us to use the CLI method from the terminal like we will do in just a minute. So I'll install this. So once we have the debugger installed, we can run it from the CLI with tau debug start. Now, when we run this command, two things are going to happen. First, the debugger will start locally, and when the debugger is running locally, the sessions that we create can connect to it. Additionally, it'll open up the debugger UI in Chrome. So we'll go ahead and call this method Tau debug start. And here the debugger has opened up. So the debugger does quite a few things, but most importantly, it plays audio and allows us to record audio as input. So we have to click here, and we'll get prompted to let it use our microphone. You don't have to, but when we use our microphone, we can input sound into ChatGPT from the debugger as well. So I'll allow that, and we get all this appearing correctly. Now that we have our debugger open, we have to make sure that our session connects to the debug server. And this is a good chance to get used to the arguments that we pass when we call create session. So create session takes 2 arguments. The first one is an object representing the session arguments. These are more or less equivalent to the parameters that are available in the OpenAI API doc. So these all correspond directly one-to-one with a session variable for real-time GPT sessions. We can leave this blank, but let's just play around with one option, which is voice. So we can pass any of the valid voices to this, and it will affect the voice that the session uses when it produces audio. We won't go through all of them, so we'll just select Ash as our voice for this session. Now the second argument is also important. The second argument is the Tau settings, which are kind of unique to this library, and we're interested in the debug setting. So I'll set debug to true, and that will cause this session to connect to the debugger and output audio directly to here, which we should hear. So we'll just leave the rest the same, so it basically outputs the same thing as before, but now it's using the debugger. And I'll call node src/index.
Websocket in tempo reale. Tau.js. Il code whisperer e tu siete davvero fichissimi.
Fantastic. So we just heard the audio coming out of the debugger right here. So now that you have this set up, you can always use this workflow to develop your audio in your real-time models using Tau.js. Take a minute to play around with the settings here, and I'll see you in the next lesson. Finally, for the last tutorial, we'll work on inputting audio from the debugger into our Tau.js session. So we saw here that we can input information into our session by using agent.user and agent.system. But what if we want to input audio? After all, most of our models that we build with real-time WebSockets are going to be used in real time, maybe on the phone, and users are definitely going to try interacting with them with their voice. But luckily, this is very easy to set up. So first, let's update the code here. So I'll delete this user message, and I'll change the system message. This is basically correct. Please translate the most recent user input to Italian. Let's just change the wording of this, but that's fine. So we'll say, whenever you respond, translate the most recent user input into Italian. And we've gotten rid of this close statement at the bottom, because if we close the agent as soon as we're done setting it up, then we can't interact with it in the debugger. And we'll also get rid of let response equal await agent dot response. So now it's using automatic turn detection from the debugger and the model. That means that it will automatically reply whenever it receives voice. Alrighty, so now I'll just go ahead and run my program with node src/index. Oh, we'll just get rid of this console log here too. So we just have the system prompt, and it's connected to debugger, and that's just it. It should just wait. So now in the debugger, you can see here it says microphone connected. Press space to start streaming. So if we press space, it will start recording audio. And if we press space again, it will stop. any audio that is recorded will be streamed automatically to the session, and the session will basically decide what to do with it. If turn detection is enabled, which it is by default, it will automatically commit the audio once a pause of sufficient length has appeared, and it will generate a response right away. So I'm going to press space and try translating something into Italian. Excuse me, which way to the furniture store?
Mi scusi, in che direzione si trova il negozio di mobili?
And it was just about that easy. So with literally less than 10 lines of code and the debugger, we've made a universal, instantaneous language translator with very good pronunciation. Take some time if you want to play around with the debugger and your session, maybe make a translator with your own voice of choice or into your own language. And remember to go ahead and star the Tau.js library and let everyone know about how helpful it is when developing with AI. Welcome back. We had a little bit of extra time at the end of this course, and also I was just having too much fun to call it quits. So we're going to do a bonus lecture now where we get to know the default voices that are part of Realtime. The current family of voices is likely to change somewhat in the future, but they're pretty interesting. So we'll get to know the voices and talk about them while we're getting familiar with them. I've deleted my file and I'm just going to write a new file from scratch just for practice. So we'll always start by importing create session from Tau.js core. And so for this one, we'll have something that performs a voice line. So we'll say let performer equal create session. And we'll leave these arguments blank for now. Let's just get to hello world first. And we'll await performer.system where we'll give it its line to speak. So we'll say please speak the following line. The rain in Spain falls mostly in the plains. I was trying to think of a clever line from one of my favorite movies, but I couldn't think of one. Feel free to put any line you want in this, as the purpose of this is just to hear how the different voices pronounce it. And then we'll say await performer.response. Now here in the session, we'll leave the first object empty and just make the second object have debug true. Now let's test it so far. I have my debug server already open from the previous lecture. I'll just open a new window, and this is the same file, so I'll say node src/index. And this should be await create session. Create session returns a promise, so if we don't await it, we don't get the session, we just get the promise.
The rain in Spain falls mostly in the plains.
Excellent. So we just got the default voice, which is the one I chose, Sage, making her response. So Sage is a cheerful female voice. It's kind of uninteresting. It is a Caucasian voice, and it does best with kind of American, Midwestern accents. I've heard it do some good English accents. So here in Create Session, we get to choose the voice of our model, and we're going to go through all of them and see how they do. So the first voice on the list, and by far the weirdest, is Alloy. So Alloy is a kind of a weird, synthetic sounding voice. Alloy is a very bad actor and doesn't act very well, but Alloy has a very interesting amount of range. Basically, sometimes it can surprise you. It has a very synthetic, loud sound to it, and it is very androgynous, not really it neither sounds male nor female. So let's see how Alloy reads the line.
The rain in Spain falls mostly in the plains.
Cool, and we can listen to that again if we want.
The rain in Spain falls mostly in the plains.
Right, so that's Alloy, kind of a weird sounding voice. Definitely not my favorite, but it has a synthetic sound that might be right for some jobs. Next is Ash. Now, Ash is a cool, masculine sounding voice. It's very European. Ash can very convincingly speak a wide variety of languages. This is definitely one of the better voices, and he does accents really well. I'm just going to add performer.close at the end of this.
The rain in Spain falls mostly in the plains.
So Ash has this kind of much more natural human-sounding voice. Ash is very versatile, and overall it's a good voice. So you're probably wondering, what is with these voices, and why can't we make our own voices? So Realtime is so powerful that it probably could, off a very small voice sample of anyone's voice, do a very convincing imitation of that person's voice. As much fun as this sounds if we just want to play a harmless gag on our buddies, this is a super dangerous aspect of the technology, since anyone could easily, if it were possible, make this sound like, the president of the United States, their school principal telling their parents they can, take the day off. All sorts of deception and fraud could be used this way. So OpenAI knows this. They're really smart, and they say you only get these 7 voices. None of them sound like anyone, and even though the technology could support it, we're not allowed to input our own voice data at all, and probably will never be. After Ash comes Ballad, and Ballad I find is pretty similar to Ash. Let's just give him a listen.
The rain in Spain falls mostly in the plains.
Right, so Ballad kind of sounds a little bit smaller, a little bit kind of more European. He's kind of got this high-pitched, harmless voice, although it is still quite masculine, and Ballad also does some pretty good accents. Next we have Coral. Coral is very interesting. Coral is a female voice.
The rain in Spain falls mostly in the plains.
So Coral really likes to ham it up. She's very loud and excited. Coral tends to be a bit too loud and bubbly. Coral is interesting. She does a lot of very interesting world accents. She does the best African accents out of any of the cast. And yeah, Coral's an interesting one with some very powerful acting ability. She's one of the best actors. Now let's see Echo. What's up with Echo? I don't even know how Echo sounds. Just remind me of the Overwatch character.
The rain in Spain falls mostly in the plains.
So Echo is kind of like Alloy. It's kind of this high-pitched, androgynous sort of voice. Not much to say about Echo except, I guess maybe it's a little bit better than Alloy because it sounds less synthetic. Now comes Sage. We'll just listen to her again. She's the voice we heard at the beginning. Sage has this kind of pleasant-sounding female voice.
The rain in Spain falls mostly in the plains.
Sage is really good for kind of like answering machines or personal assistants. She just has this pleasant voice that you would associate with something like a customer service or a personal assistant. She's kind of like kind of remind me of Pepper Potts, which is her Iron Man's assistant, although Jarvis is really the computer that he uses. So I'm kind of getting them mixed up, but she still reminds me of Pepper Potts. Now Shimmer.
The rain in Spain falls mostly in the plains.
Yeah, so Shimmer's pretty interesting. I can't really super tell her apart from Sage, but she's there. She's her own voice. She's a pretty good actress. And then last but not least, we get Verse. I find Verse is very similar to Ash. So Verse is kind of this raspy male voice.
The rain in Spain falls mostly in the plains.
So with Verse, you get this very kind of generic male voice, also kind of more high-pitched. But of course, you can change the way of any of these voices communicate. We're not going to go too much into detail about modulating it, but you can use a system prompt or instructions to make the voice speak in an accent. So let's just do that once. We'll say, wait, performer.system, speak all lines in a raspy, deep Scottish brogue. And the model will do its best to respect this, especially the GPT models. The mini models are not so good with the accents, but yeah, so you can make any of the voices talk in any of the accents, and each one kind of is better or worse or more consistent at the accents. Verse is very consistent with a Scottish accent, as are most of them. So let's see the same line with a Scottish brogue.
The rain in Spain falls mostly in the plains.
Sweet. So totally convincing Scottish accent. There's a whole lot to unpack in this short tutorial we just did. Obviously, there's a huge amount you can do with these voices. They're very sophisticated. Now, we've both done a quick walkthrough of them and also even got a bonus little tutorial on making them talk with accents. So I hope you enjoy that. Once again, remember to follow this library to start it, and we'll be back for another tutorial soon.